So let me restart. Let me go over. So I've created a person class. Okay, this person class has three properties, three fields. Okay, the first is their name, their age, and their phone number. It can have as many properties as we want to give to it, but in this case I'm just defining these three properties, these three members for our person class. And I have a constructor for the class, and this constructor accepts parameters for all three fields. Cool. So and over here I'm creating a list, okay, or an array. So as we were saying, this is the syntax for creating. Let me start. This is the syntax for creating a list. Okay, in this case I'm choosing to make my list final. So what's the variable name I'm giving to this list I'm creating? I'm calling it persons. Okay, and we know we use these brackets to define that whatever goes inside of it is a list. Okay, so if I hover over persons right now, we'll notice that it's a list of dynamic items, which means we can put any items. I can put a string here, I can put an integer, I can put anything. Okay, and it wouldn't flag me because the type is dynamic. Okay, now it's changed to object because everything inherits from object. If you have nothing inside of it, it's dynamic by default. But don't worry about any of those things. With this our list, we want it to have want it to hold persons. And when I introduced us to lists, I remember I said if you want, a list can hold any items at all. Okay, it can hold integers, it can hold strings, or anything you can think of. A list can hold it. Okay, a list of persons, a list of numbers, or anything. So if you want to do that, you just introduce the angle brackets before the brackets, and then you put the type in there. So if I want this to be a list of integers, I'll specify the type here. Okay, if I want it to be a list of strings, I specify that over here. So whatever type I want my list to hold, I specify it within the angle brackets. In this case, I want to create a list of persons, which means the items in my list are going to be person objects. So I define the type as person, which is a class I have created over here. Cool. So now that we have our list, let's try to put some default values inside of it. So the first, I'm going to create a person here and give this person a name of John Adu, say, yeah, and let's give him an age of 20 to 23. Cool. And a phone number 024 is a string. Yeah, the phone number is of type string, so 024, sorry, 0245. Okay, so I have the first item in my list. Let's duplicate that. Change some of these values. Owusu, Kwame Mensah, Michael, Edu, Andrew, therefore let's say we have V Johnson. We na mema, let's add okay. Ja something cool. Let's just change some of these. You see this one is 26, 18, 20, 25, 24, okay, 29, 22, 19. Let's leave the phone numbers like that. Okay, so what we have here is a list of person objects. Okay, and this list has 1, 2, 3, 4, 5, 6, 7 items inside of it. Okay, so we know from the previous classes that to create a for loop, use the keyword for, open parentheses. Within the parentheses, you create and initialize your what do you call it? The iterator, something cool. Okay, so let's say I equal to 0, and then the limit, we're going to loop until I get to the last item within our list. To get that, our list dot length, then -1. Okay, remember arrays are indexed from 0, so the last item in the array is going to have an index of the list, of the size of the list, -1. So that's here. That's what we have here, and then we are going to be increasing by 1. And then within our loop, let's say for now, you're just going to print. Wait, you're just going to access the item within the list and print their names. So far, everything is okay. So what we are doing here is we are looping from 0 to the last item in our list, and during each step of the loop, we just print the person's name. Okay, so initially the list is initially we are starting from 0, so there's the item with index 0, so we'll print their name, John Adu. Then we increase I to 1, so there's an item with index I. With index 1, we print Jinosu until we get to the end and print Yabudu. So let's see how that runs. Okay. So as expected, the names of the persons in our list have been printed to screen. Okay. So we have this. There's something we are already used to. We've done this in Java, and okay. I don't know. Maybe we've done it in that as well, but no worries. But yeah, so this is how you write a standard for loop. This is how you write a standard for loop. But when you look at this particular code, you realize that we didn't use this indexer to do anything. The only thing we used it for was to retrieve an item at that particular index, and then we worked on that item. That's the only thing we use this for. So most programming languages introduce a simpler way to actually do this, and that's the for each loop. When you take this person's list here, okay, it has so many methods on it. Let's see. So when I do the accessor, the dot, we see all the items, all the things we can do with our list. We can access its length. We can get a reversed version of this list. But what I'm looking for right now is a function on lists called for each. Okay, so this function for each. Let's see what that is. This for each function right here is a function that invokes an action, and it invokes an action on each element of this iterable. An iterable is just anything you can loop over. So a list, we can loop over a list, so it makes a list an iterable. Okay, so this for each will invoke whatever action we specify on the items within the list we want to loop over. Okay, in this case, we are looping over our persons list. So whatever action we specify inside the for each block will run on the items within the list. Okay. Now, let's analyze this for each method. It's accepting a parameter that's a function. Okay. A function that does not return anything, indicated by void over here. And this action accepts a parameter of type E. This E is just whatever type our list is holding. Okay, in our scenario, our list is holding persons, so the E will be person. So we need to pass a function to this for loop. First of all, let's define a function somewhere inside here. Let me define it outside. We know the syntax for defining functions. The for each, like I said, it accepts a function that takes a person as a parameter, and it doesn't return anything, as indicated here, void function person, and the function's name, the parameter's name is action. Cool. So this is a function that does not return anything, but it takes a parameter of a person. So let's define a function that has that particular signature. So a function, let's call it action. Let me just call it my function. Cool, no problem. Okay, this function has to accept a parameter of type person. So person. Okay, so we have this function, and this function, let's say whatever it will do is just print it will print the person's name, just like this for loop is doing over here. So we're going to try to achieve the same thing, but with the for each. So like I said, this for each accepts a function as a parameter. We have created that function here as my function. So I can pass my function to my for each. And I can leave it like this. And or we can just, yeah, so that's it. Okay, so we have created a function that has the same signature as what our for each expects. Okay, therefore each expects a function that returns nothing, indicated by void here, and that function has to accept a parameter indicated by the person type here within its parentheses. Okay, we have created an exact function that has that signature. Okay, but first of all, let's run this code. Let me comment this one out. Let me comment this out and run this code. We expect that we get the same result as we had previously. Cool, as expected, we have the same result, that all the names of our persons have been printed to screen. Okay, but so does this mean that this mean that every time we want to use the for each, we have to come and create this function and pass it to it? No, we don't have to. Okay, we don't have to create this function separately. Let's see again. This function has the same signature as this for each expects, but this function, it has a name. It's a named function. Its name is my function, but there's something we call anonymous functions. When we say something is anonymous, it means it doesn't have a name, or we don't know its name. Okay, I think that's how the English dictionary will define anonymous. Okay, anything that doesn't have a name, or anything whose name we don't know, that's anonymous. So in programming as well, we have functions that can be anonymous. Even some programming languages have classes that can also be anonymous. Or okay, they have anonymous classes, anonymous functions. In this case, we're going to use an anonymous function for each. Like remember, like as I said, an anonymous function is a function that just doesn't have a name, which means to make our main function anonymous, we just have to get rid of its name, right? So if I get rid of its name, it becomes anonymous. Okay, we are getting errors here, but no problem. That's because an anonymous function cannot exist on its own. It has to exist within some context. Okay, so this is all an anonymous function is. So let me just move this guy and replace this my function variable with our anonymous function, and we have our error solved. Do you get it? So instead of coming down here to create your function, we need to do some job. You can just pass that same function, but without its name, to the for each. I hope it's clear and it's not confusing. So now that we know what anonymous functions are and how we can use them in our for each, let's run this code and see if we get the same result or otherwise. Exactly. So we have the same results as we got in the previous two tests. Okay. So let me get rid of this commented code. And you realize there is an easier way to loop over lists than to have to write this whole for loop and manage the index yourself. God forbid you make a mistake and you don't introduce a -1 and you start getting array out of bounds. Okay, so the for each makes this code simpler for you. So I expect you get onto using those. Okay. Now let's see how we can use this whole thing we have learned to build UIs. See how we can use this to build UIs. Let's go into our main, so our home page. And with the same idea, let's create a list. Let's create a list of students. There's going to be persons. Okay. It's going to be of type person. And this, yeah, let me just bring this whole thing, our samples. If something is not clear, you can ask away and we'll go over it again. So I have here a list of persons called students. Okay, so we are going to display these students in our UI. Let me run this thing in the background. Oh, first of all, let me run this in the background while we work on this. So we are going to just create a simple UI where we'll print the names of these students on the screen. Okay. So within my scaffold, this is just going to be something raw. So just the body. In traditional context, you probably say we are going to use a column. You probably say you're going to use a column, and with the children, you will loop. You create a for loop or something. Let's say the for each. So persons, students. Sorry, students. Not for each student. Yeah, there's one thing I didn't talk about over here. This for each function, it knows that it's supposed to accept a function that takes a person. Okay, it knows because we are calling it on our persons list, so we don't have to specify the type. We can just specify the name of the variable. Okay, so if you see over here, just elements, and there's no type, there's no person type over there, it's the same thing. Okay, it's because it knows the type, so we don't have to specify it. Okay, in the traditional sense, you might consider doing this: create a column and then loop, and then with each one, let's say we are going to use a text. So we're going to use a text widget, and then we are going to print elements. Let me just change this to person, so to student, so it will be more familiar. Student.name. Okay. Let me fix this bug. Okay, so we can't use the for each here because it doesn't return anything. Anyway, I hope I'm not speaking to the void and we can all see and hear what I'm doing. Okay. So let me get rid of this. So in the more traditional sense, you probably would consider doing something like this. You probably would consider doing something like this, or using the traditional for loop, where you create your I, So I is less than students.length. And then within this, we can have we can access them by the index. Okay, so you can do something like this. Let me introduce some padding around our this thing. Okay, so as you can see, we have our items listed on the screen. Okay, we have the names of the students as expected printed to screen. You probably consider doing something like this in the traditional way we have treated loops and all, but using the column to do something like this is inefficient. Okay, it's inefficient. There's a widget that exists to make a job like this very, very simple for you, and that's the list view widget. Okay, it's you use a column if you have only a few items to display, and all those items are different. Okay, all those widgets are different. Let's say the first item in your column is going to be a text, just an example, and the second item is maybe going to be an image. The third is going to be a card. You see, these are all different items. So with that one, it makes sense that you just define a column and put these items in there. But if all the items within the column are the same, like we have here, they are all just a text printing a name. Okay, it's not advisable to use a column to do something like this. So let's convert this to incoming. Let's convert this column into a list view. Let's convert this into a list view. So let me cut all of this out. The list view is basically another widget. Okay, the list view widget. If you hover over it, you see its description is it's a scrollable list of widgets arranged linearly. Okay, a list of widgets that can scroll. A column cannot scroll. So let's say with this first example we used a column. Let's assume the items in a column were so many. Let's say there were 1,000. Okay, because the column cannot scroll, and we have to display all these 1,000 items. How are we going to like navigate through all these lists? Okay, so the column is not equipped to scroll. If you want to be scrolling through items of the same type, you just go on and use your list view so you can scroll. This list view widget has a special function called the builder. Most times you'll be using the list view, you'll be using the builder function. Let's see what the builder function is and how it operates. Okay. It accepts an item builder function. Remember, we spoke of these function things, these anonymous functions, like I demonstrated here. Okay, this for each function accepts another function. That's an anonymous function, like I've done here. The same thing with this item builder. Okay, it also accepts an anonymous function. A function, in this case, this anonymous function returns a widget. Okay, therefore each returns void. Its return type is void because it doesn't return anything. Okay, but this one it accepts a function that returns. It accepts a function. Where is it? Okay, item border rather. Sorry, it's It's a function that returns a widget, and this function accepts two parameters: build context and an integer. Okay, this integer here is the index of the particular item we have gotten to in our list. Okay, just like the for loop we create an index. Say usually we use the I. That's that tracks the index. Okay, so whatever function we pass as our item border has to take two parameters: a bold context. Don't worry about the bold context. Okay, a bold context and an integer. The integer being the index. So let's try and create such a function here. Again, if we were to create the function outside, we just create a function that returns a widget, create it within the class. Function that returns widget, let's say bold widget. Let me just call it item border. This item border function, like I said, it accepts a bold context and an integer. So bold context and integer index. Okay, so we have this function. It has to return a widget. So for now, let's just return, say, a container. So I can pass this item border function here, and as you can, it's already seen it because it has the same name, item border. So just so you don't get confused or anything, let me just rename this to my item border and pass that as the function we want to use. My item border, you see. So what will happen here is this list view is going to call this item border function. Like its name suggests, it's a function that will build the items that the items we want to display in our list. In this case, we want to display a list of just texts. Okay, so we want to display this function must know how to build the individual items. So let's do that. Instead of returning a container, let's just return our text, and this text is going to print our students. We'll get the particular students at this index and pass their names. Okay. It's building. Let's see what happens after it's done. As it's building, if you have any question, you can please ask. Oh, this is taking long. Wow, time is almost up. Okay, so we have our first error. We have a range error over here. How is it getting 7? We have a 1, 2, 3, 4, 5, 6, 7 items. So the last index should be 6 and not 7. This is strange. Abankwa. Hello. Hello. Mr. Mike.
Yeah.
It looks like we are the only ones here.
Hi, James.
Yeah, Abankwa. Yeah, do you have any idea why this is happening? Okay,
Come
for now,
again.
let's do this. Yeah, I was asking if you knew if you had any idea why this was happening. For some reason, it's trying to access an item of index 7 when the last index is 6, and I'm not manually handling the indexes. It's handling it all behind the scenes by itself. But anyway,
Let me see.
okay, I think I have to specify the item type, the count.
Yeah. So that'll be
Michael is the
list.length.
yeah. Michael happens to be the only one around. I don't know. It's like the others are not interested anymore. Okay, so this fixes our error. So the list view border accepts so many parameters. Okay, the first one, let's forget about the key for now. We won't talk about keys anytime soon. It accepts an axis. The axis here, it accepts a scroll direction, and that's of type axis. The scroll direction, that's in which direction you want to scroll. Do you want to scroll vertically or horizontally? The default is vertical. So if this list happens to be longer than this screen can accommodate, we'll be able to scroll in the vertical axis. It also has the item count, which we just specified over here. The item count is how many items we want, how many items are going to be in our list. In this case, we know in advance, we know how many items are going to be in a list because we have the list we want to display. It's this list of students. So we specify that as the items, as an item count. Item count is whatever size our students list is, and it will base on that to generate to build our function, to build our view. But now what I want to do right now is I want to change this my item border function from a concrete function to an anonymous function. So let's go and do that. Again, as I said, anonymous function doesn't specify its name. That's how it's anonymous. So we just get that part, we get rid of that part, and we put what's left over here. And voila, we have the same code. So usually that's what you'll be doing. You won't be creating a function somewhere and then you will dump it here. Unless maybe the function is present in some other place you've written your code, and then fine, then that's okay. But for these ones, that's how we're going to be doing it. So subsequently, I won't create the function outside and put it here. I'll just go straight and use an anonymous function. Okay. So let's go on and try and make this thing a little bit beautiful. Instead of displaying just a text, let's use a container, and for the child is going to be a column, and within this column let's make the child a row. And this row's children, the first item in the row is going to be a circle avatar. And this circle avatar is going to have as a child the first is going to have as a child a text, and that text is going to hold the first item, the first letter in a person's name. So for John Doe J, as usual, like that. So how do I get that? To do that, I have my list. It's a list of students. I pass the index to get a particular student in question, and then I get their name, and on their name there's a function present that I can use to retrieve the first item. I can use a substring, but let's save this. If I can treat it this way. 0. Okay, yeah, so okay, so what I'm doing here is I'm getting the particular students we are on. So let's say the first time we are running, the index is 0, so we are getting the first student over here. That's John Doe. And what I'm doing is I'm getting the name of this student. That's John Doe, and I'm taking the first letter in their name, indicated by this 0 here. So the first letter in their name. Okay, so I have that. That's the first item. That's the first item in my row. And the second item in my row, I want it to be a column. I want it to be a column. And this column's children. This column's children is going to have the first item be a text, and this text is going to be the student's name. And the second item here is going to be the student's phone number. Let me just display the age instead. We have an error here. Let's see what it's about. It's saying the argument type int can't be assigned to the parameter type string. As we know, text here accepts a parameter string, and the age here is an integer. That's why we're having this issue. So while I can just wrap this, I can just use a string interpolation we spoke of last time. To convert this into an integer, into a string, and have it be displayed. There's an error somewhere in my code. Okay. So let's see how this looks. Okay, so it's coming along. Let's try and make it a bit beautiful by first of all giving this container some decoration. We have done all of these things in previous classes. Box decoration. What shape should I even give to it? You know what? Let's use a card instead. I think we learned cards recently, so we can give it some elevation. Let's give it an elevation of say 4. And what else does the card accept? The card also accepts a shape. So let's give it a box shape. A box shape. Yeah. Rectangle. Okay, that doesn't work. How many shapes are there? Okay, there's an outline shape border. There's also, how many shape borders are there? Let's use outline shape border. Outline border instead, sorry. It's also obstruct. Wow. All right, I think we'll deal with this later. Okay, so let's give our card some padding by wrapping our rule. Or the card, does the card have a padding? Okay, card doesn't have a padding. So let's wrap this rule. Okay, so it's coming alive. We have these items in our list. So as many items as we have, we can do something like this and arrange these things a little bit nicer. Let's give this main axis alignment. Start. So we're across. No, not the row. A column instead. Give a column a main cross-axis alignment. Okay. And let's put a space between the avatar and our column with a sized box. Let's give it a width of say 15. Okay. So this is basically how to, how should I say, this is basically how to use a loop. This behind the scenes, it's using a loop to display these items in our list. Okay, if we weren't using a list view and we chose to use a column, we would have to create these items one by one. We have to write cards for each of these. So if there are 1,000 items, it means we have to write 1,000 cards within here, which is inefficient and it's actually a waste of time. So the list view helps you to simplify this process by creating it just once, and then for each item within our list, the list view will just run our item border function and generate the card rather than we having to code it ourselves for all the items within our list. Okay, so yeah, if there's any question, I think the time is up. If there's any question or any inputs from our tutors, please you can bring them in. Hello. Any questions or inputs?
I'm okay.
Okay. Boss Amankwa, he says he has poor internet. Okay, so anything from any of the previous classes you'd want us to maybe go over or anything? Or we can end the class. Okay, so I think
Yeah,
let's okay, I guess that's it then. So this is a basic demo of how to use the list view widgets, how to the various loops we have, the for loop, the for each, and how the for each makes certain things even way simpler than having to use a for loop. Yeah. So I guess I'll find some assignments and post it on the page that will involve what we have done here today. So in the absence of any other thing, thank you for joining today's class and see you, God willing, Monday.
Thank you.